Hello everyone! To start with the topics on analytical approaches to modern geometry, let's start with the topic on vectors. Specifically for this video, we are going to introduce the vector addition and scalar multiplication for vectors. Let's consider two vectors in R squared or R2 or in Euclidean plane where x and y have the following components. X is the in the R2, it's actually a point in the Cartesian plane, x sub 1 and x sub 2. And then we have here y sub 1 and y sub 2 for the components of y. And let C be a scalar, a real number. So to illustrate vector addition, if we are going to add the two vectors, x and y, the vector addition allows us to add the components, the first components and second components respectively. In short, this will be equal to, of course, we are actually having this. These are their equivalents, right? You have here x sub 1, x sub 2, and y sub 1, y sub 2. For vector addition, simply add the components, x sub 1, and the first component for your y, which is y sub 1, and then your second components, x sub 2, and y sub 2. This is how we add vectors. We simply add the first components and then we add the second components. Take note that the resulting here will only contain two components as well. This means that whatever be the result for a vector addition, this is also an element of R2. This would mean that vector addition is closed under R2. For the scalar multiplication, that is if we are multiplying scalar C, in this case, for vector x or vector y, this is just equal to multiplying C to the components of your x, which is x sub 1 and x sub 2. Simply use the distributive property, you will get here C, x sub 1, and C, x sub 2. And as you can see, we also have two components. This is still an element of R2 or R squared. This would mean that under scalar multiplication, the scalar multiplication of vectors is still closed. So we are going to use this as we will proceed to operations later on. But the next few videos will talk about some properties that will be used to further illustrate the operations on vectors. Thank you very much for watching.